In this second half of section 9.8, we're going to continue to look at the power series, and we're just going to look at that third situation where the limit of the ratio is not 0 and it is not infinity. How do we handle it when that is the case? How do we check the endpoints for convergence or divergence? So I've split this into two videos so that you don't have an hour video to watch, you have two shorter videos to watch. Let's take a look at another example, and this is going to be the most difficult type of example because we're going to be dealing with an interval of convergence that is not, or a radius of convergence that is not 0 and not infinity, but instead it's going to be some other value. And in that case, it's going to be more difficult because we're going to have to do some extra steps to determine the interval of convergence because we're going to have to check the endpoints, which we haven't had to do yet. The good news is I'm still going to start the same way I did before. I'm going to start by finding the center, which is very easy. The center here is 1. And then I'm going to think about what's a sub n, and that is radical n, and then x minus 1 to the n. And then what's a sub n plus 1? Well, that would be radical n plus 1, and then x minus 1 to the n plus 1. I'm still going to perform the ratio test, so I'm going to find the limit as n approaches infinity of the absolute value of a sub n, which is radical n plus 1 times x minus 1 to the n plus 1 divided by radical n times x minus 1 to the nth. We're still going to use those same tricks that we used before to reduce anything that we can. Now, x minus 1 to the n plus 1 is going to be written as x minus 1 to the n times x minus 1. And that is so we can cancel x minus 1 to the n. However, I can't do anything to reduce these radicals. So my new expression is the limit as n approaches infinity of the absolute value of the square root of n plus 1 over n. So I'm just writing it as one radical instead. And then I still have this x minus 1, and I'm just going to write it out here because it is not affected at all by n, just as we did before. Now, when I did this before, this limit turned into 0, or this limit turned into infinity, and so this was a non-factor, and that's not going to be the case here. So as I continue through this question, you can again think about the fact that as n approaches infinity, this 1 is not going to be really taken into account, so it's the square root of n over n, or the square root of 1, which is 1. Or remember, we also talked about how you could use that rule. It won't let me erase, we get the idea. We can use the rule that says, what if I take my values in my numerator times 1 over n, and my values in my denominator times 1 over n, and that's going to give me 1 plus 1 over n over 1, and then still x minus 1. And so what's going to happen here is, again, whichever way you think about it, this limit is going to be 1. So I have 1 times the absolute value of x minus 1. Now, from here, this is where we haven't had to do this before. What I need to do is, this is that third option where I say, I want to determine where this is going to converge. And that means I need this expression to be less than 1. Always less than 1. Now, if I had a value other than 1 here, I would multiply each side by that value, but I don't need to do that. So I'm going to think about the fact that I have the absolute value of x minus 1 is less than 1, and using the properties of the absolute value, actually before I do that, I'm going to go ahead and determine the radius, and the radius is going to be 1. because as I rewrite this, this is going to be -1 is less than x minus 1 is less than 1, and adding 1 in each direction gives me 0 is less than x is less than 2. Remember, the center was at 1, and the radius is from the center to the endpoint. So from 1 to get to 0 is 1, and from 1 to get to 2 is a distance of 1. So my center is 1, and my radius is 1, and up to this point, my interval of convergence is 0 to 2. But the problem with this is I don't know if it's 0 to 2 with open intervals, open interval on 0, closed interval on 2, closed interval on 0, open interval on 2, or perhaps closed and closed. So that's the next part that we're going to look at, is how do we determine the endpoints. So just to recap, up to this point we have found that C was 1, the center is 1, which we found just by examination, and we did a lot of work to find that the radius was also 1, and that is how we then found 0, 2. We said, well, if C was 1, then C minus R, comma C plus R is how we found our interval, which is 1 minus 1, comma 1 plus 1, which is of course where we came up with 0, comma 2. But now the question is 2 included? Is 0 included? And what we're going to do to check the endpoints, and we haven't had to do this yet, is simply to look at this again and let x equal 0 and let x equal 2, and then we're going to determine convergence in that way. So if I let x equal 0, then I have the summation as n goes from 0 to infinity of radical n, and then this is 0 minus 1 to the n. So the summation from 0 to infinity of radical n over -1 to the n. So what happens to each of these things when n goes to infinity? Well, this is the square root of infinity, which is infinity. And this is going to oscillate back and forth between -1 and +1. So essentially, I'm going to get infinity, negative infinity, infinity, negative infinity, infinity, negative infinity. And long story short, that means this diverges. So if this diverges, then that means when x is equal to 0, I should not be including 0 in my interval of convergence, which basically just means I'm going to leave this as an open interval at 0 and not a closed one. Looking similarly at x equals 2, the summation as n goes from 0 to infinity of radical n over, now I'm replacing x with 2, so 2 minus 1 to the n, which is the summation as n goes from 0 to infinity of radical n, and then 2 minus 1 is 1, and 1 to the n is always 1, so I'm not even going to worry about that. But as we know, this still is going to give me infinity. And so even though it's not oscillating like this one did between positive infinity and negative infinity, it's still not a value, so it still diverges, which means what is my interval of convergence? Is just what I thought it was to begin with, convergence. I think I put a few extra letters in there, but both of these are going to be open intervals, so 0, comma 2, and again parenthesis on each side, so neither is included in a bracket form. Remember, bracket would be if it were included, so both of these should just be parentheses. Let's look at one last example, and the reason I want to do this example is just to give us a little bit more practice on verifying those endpoints. So obviously this is going to be a situation 3 where I have to determine the convergence or divergence of each endpoint. So remember that I'm really looking for the center and the radius and the interval of convergence. And those are going to be my final answers, but there's going to be a lot of work required to get there. The center should be very easy. I should be able to look at whichever expression involves x to some power of n and think about what is being added or subtracted. So I'm subtracting 3, but remember we're expecting subtraction, so it's positive 3 is the center. Now what? Well, now I'm going to use the ratio test. And the ratio test says to find the limit as n approaches infinity of a sub n plus 1 divided by a sub n. And typically I've been writing those values over here, and you can do that, but it's not necessary. So I'm not going to in this case just for the sake of time, because this video is already way longer than I normally like to make videos. So I have the limit as n approaches infinity of, I'm going to take everything here, and every time I see an n, I'm just going to add 1 to the value. So this is x minus 3 to the n plus 1, or n plus 2, divided by n plus 1, which is n plus 2, and then 4 to the n plus 1, or 4 to the n plus 2. I'm going to divide it by the original function, but I'm actually just going to multiply by the reciprocal because I'm too lazy to recopy it yet again. So n plus 1, 4 to the n plus 1, and x minus 3 to the n plus 1. Reduce anything that we can using the same strategies that we've been using. So this is going to be rewritten as x minus 3 to the n plus 1 times x minus 3. So that I can now cancel x minus 3 to the n plus 1, leaving me with just the x minus 3. And then another thing I can rewrite is 4 to the n plus 2 can be rewritten as 4 to the n plus 1 times 4, so that I can reduce 4 to the n plus 1. And then I'm just going to box off everything that's left over so that I don't forget anything. Now what I'm going to do is I'm going to actually separate out the values that are dependent on n and those that are not. So what's not dependent on n? Well, I have x minus 3 in my numerator and I have 4 in my denominator, neither of which have anything to do with n. And now I'm going to say that is multiplied by the limit as n approaches infinity of everything that is dependent on n, which is n plus 1 over n plus 2. Now I hope at this point, because we've been doing this for what feels like 100 years, we should be able to determine that the limit as n approaches infinity of n plus 1 over n plus 2 is equal to 1 without a lot of hubbub. So I can think about it just using the influential terms of n and n, or I can divide everything by 1 over n. I honestly don't care which way you think about it. What I do care about is that you understand that what I'm left with is just this, because I have the absolute value of x minus 3 over 4 times 1, because that is the limit, and that leaves me with just x minus 3 divided by 4, the absolute value. Now, we've talked before about the fact that we want that expression to be less than 1, because that's what the ratio test tells us will converge. So I'm going to set the absolute value of x minus 3 over 4 to be less than 1. Now when I have the absolute value, remember I can instead write this as negative 1 is less than x minus 3 over 4 is less than 1. And this is just algebra. Take everything times 4. Negative 4 is less than x minus 3 is less than 4. Add 3. Negative 1 is less than x is less than 7. Stop here and determine the radius. So the question is, I know my center is 3. What does it take for me to get from 3 to 7, or from 3 to negative 1? What's that distance? And that distance is 4. And again, I can just take 7 minus 3 to determine that that distance is 4. So that's my radius. So now I have my center and I have my radius. And I almost have my interval because my interval is -1 to 7, but the big question mark is, should there be an or equal to here or not? Or should there be a bracket as opposed to an open interval, which is really the exact same question. So that's what I have to do now. I need to plug in x equals -1 and determine what happens when I plug that in. And then I'm going to do the same for 7. So starting with x equals -1, I'm going to take my original expression, the summation as n goes from 0 to infinity, and instead of x I get -1. So -1 minus 3, which gives me -4 to the n plus 1 over n plus 1 times 4 to the n plus 1. Our job is always to simplify anything that we can. So I'm going to continue with the sum as n approaches, or n goes from 0 to infinity. I'm going to rewrite my numerator as -1 to the n plus 1 times 4 to the n plus 1. My denominator is still n plus 1 times 4 to the n plus 1, so that I can cancel my 4 to the n plus 1s. So now I have the summation as n goes from 0 to infinity of -1 to the n plus 1 over n plus 1. This is the point at which I'm going to think of another test. This is a brand new series, and I need to think of a brand new test to determine convergence of this brand new series. So I'm going to use the alternating series test that says if you're going to use the test, you first check if the limit as n approaches infinity of everything that does not include the alternating portion of your sequence, so in this case 1 over n plus 1, does that converge to 0 or not? And this one absolutely does converge to 0, and therefore that condition is met. The second condition for the alternating series test is to determine a sub n plus 1, and again that includes this function not including the -1, so that is 1 over n plus 2. And how does that compare to 1 over n plus 1, which is a sub n? And obviously if this guy is bigger, which it will be, then it's going to be a smaller overall fraction, so that would be less than or equal, and that condition is met. And therefore, because both conditions are met, this converges by the alternating series test, and therefore that tells me that x equals -1 is included, which tells me that this is a closed parenthesis at -1. And I know this is 7, but I don't know if it's an open parenthesis or closed parenthesis, so that's my last step. X equals 7. When I plug in x equals 7, I'm going to move that down a little bit. We're going to try to fit this all on one page because we're that brave. So the summation as n goes from 0 to infinity, I'm replacing x with 7, which gives me 4 to the n plus 1 divided by n plus 1 times 4 to the n plus 1. 4 to the n plus 1 obviously cancels. That gives me the summation as n goes from 0 to infinity of 1 over n plus 1. Now again, from here I need to decide what is my best strategy. What's the best rule that I can use that fits all of the requirements of that rule that can help me to determine convergence or divergence. Now I know that the harmonic series is 1 over n to the first, and I know that that diverges. So I can use the limit comparison test. And the limit comparison test says if I take the limit as n approaches infinity of 1 over n and 1 over n plus 1, so this is going to be the one that I'm comparing it to. And then I do just a little bit of cleanup, which would be the limit as n approaches infinity of n plus 1 over n. What's going to happen? Well, gosh, this looks really familiar, doesn't it? It's the same concept. This limit is equal to 1. And the limit comparison test says if you get a limit that is finite and positive, and it is both finite and positive because it's greater than 0 and it's an actual value and not infinity, then they both converge or they both diverge. Well, I already knew that this guy diverged, and so therefore this diverges by the limit comparison test, which means 7 is not included, and that should be an open bracket. Your textbook includes another portion of section 9.8 that talks about differentiation and integration with the power series. I'm not going to ask you to know any of that, so I'm not going to go through it. I'm not going to ask you on a homework or quiz or a test. We are going to move on to section 9.9, which is representing functions with the power series, and we're going to start with the geometric power series.